Hello everyone. In this video we are going to discuss about methods of voltage control by reactive power injection. Today's topic is reactive power injection. This is our today's topic. We discussed in our previous video only the methods of voltage control, not in specific about reactive power injection. This video we are going to discuss this specific topic, reactive power injection method. Okay. The conventional means of reactive power injections are, first one is shunt capacitor bar reactors. Second one is series capacitors, and lastly synchronous condensers. Okay, these are the conventional means of reactive power injection. First one is shunt capacitors or reactors. Let us discuss in detail about all the three methods. Let us discuss firstly shunt reactors. Shunt reactors are used to compensate the effect of line capacitance. If we are having any line capacitance on a transmission line, we are going to use these reactors. Okay, firstly these are used to compensate the line capacitance. Okay, to limit the voltage rise. Okay, if you are having any line capacitance, the voltage may increase rapidly. So in order to compensate that, we are going to use these shunt reactors. What happens if we doesn't introduce any shunt reactors? If there is any line capacitance, the voltage keeps on increasing from the sending end towards the receiving end. If we are supplying, let us assume we are supplying a 230 volt. If you are having any line capacitance, the voltage keeps on building towards the receiving end. It would be nearly 300 or 350 volt. Okay, the raising in voltage will cause a Faraday effect, and we all know if the receiving end voltage is greater than the sending end voltage, okay, we call it as a Faraday effect. Okay, just to keep that in mind, we are using these shunt reactors, okay, to compensate the effect of line capacitance. Okay, and secondly shunt capacitors. These shunt capacitors supply reactive power at a bus and are used with lagging loads. Okay, if you are having any lagging loads, which means the inductive load, if you are having any inductive load, the voltage keeps on dropping due to reactive power consumption. Okay, to compensate this, we are going to place the shunt capacitors. Normally we place shunt capacitors at the load end, okay, to compensate the effect of this reactive power losses. Okay, sometimes we use permanently these capacitors, shunt capacitors are placed permanently, or we may use it as a switching devices. Okay, whenever needed we are going to switch these things. Their main advantage is low cost and are flexible. Okay, compared to other compensating methods, these are very flexible and are low cost. Okay, these shunt capacitors are also extensively used in distribution feeders for power factor improvement and for feeder voltage control. Improving the power factor will leads to maximum power transfer. Okay, and connecting a capacitor at the load end compensates for the lagging current drawn by the load. By compensating the lagging current, we are going to improve the power factor. Okay, this is about shunt capacitors. And our third one is series capacitors. These series capacitors are connected in series with the line conductors. Remember, we are going to connect in series with the line conductors to compensate the inductive reactance of the line. Okay, to compensate the inductive reactance of the line. Okay, the uses of these series capacitors are we are having wide range of uses. That first one, it reduces line losses. Second one, it limits load dependence. Load dependent voltage drop. Influences power flow in parallel lines. It increases steady state power transfer capability. Steady state power transfer capability increases system stability, okay, and it reduces transmission power angle. Okay, these are all the uses of series capacitors. Okay, series and shunt capacitors are having their unique uses and advantages as well as disadvantages. Okay, in the next video we are going to compare series and shunt capacitor differences. Okay, now we will continue with this next point. As we all started with our methods, shunt capacitors bar reactors, series capacitors, and synchronous condensers. We completed shunt capacitors, reactors, series capacitors. Now we are left with synchronous condensers. Let us see what synchronous condenser is going to deal with the reactive power injection. These synchronous condenser are nothing but synchronous machines running with no load, or running without a prime mover. We can also call it as a synchronous motor running with no load. Okay, synchronous condensers are nothing but synchronous motors running without load. Okay, these synchronous motors or synchronous condensers without no load, when connected at a bus, it can control the bus voltage, control the bus voltage by absorbing or generating reactive power. Okay, it is going to absorb the reactive power or it is going to generate the reactive power, one and the same. Okay, let us consider a system. We are having a supply and a load. Okay, 230 volt to 50 hertz we are transmitting. Okay, if we are transmitting a power of about 10 megawatt for time being, let us assume. Okay, not actual numbers. If the load is 10 megawatt, we are supplying 10 megawatt and the load is 10 megawatt. If the reactive power is 2 megawatt, here we are. Okay, reactive power is the actual load. Now we need 2 megawatt of extra power to be transmitted. Okay, which is a burden for the supplier. If you are going to place a synchronous condenser near to the load, connected near to the load, and this is going to supply 2 megawatt, which means this synchronous condenser is going to absorb this 2 megawatt, so that 10 megawatt is supplied to the load of 10 megawatt, or synchronous condenser is supplying 2 megawatt, compensating the reactive power of 2 megawatt. Okay, both are one and the same. This is how we are going to use a synchronous condenser to compensate the reactive power. This is about the methods of voltage control by reactive power injection. If you have any doubts, please do a message on my Dropbox. Thank you. We'll catch up in our next video while comparing the differences between series and shunt capacitors. Thank you.